Hello and welcome everyone to another session of the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Shishir, part of the data science team at Analytics Vidhya, and I will be the moderator for this session. For those who have joined us for the first time, a brief introduction about the DataHour sessions. The DataHour is a series of webinars conducted by Analytics Vidhya, led by top industry experts. It's a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, our today's session is on the topic Introduction to Tensorflow Javascript. In this data hour, we'll start with the basics of deep learning and then proceed on to see real cool live deep learning fundamentals and later how Tensorflow Javascript does it and much more. In this edition of Data Hour, we have with us Umang Sharma from Delhi, India. Umang is a senior data scientist with years of experience building deep learning solutions in multiple areas of computer vision, natural language processing, reinforcement learning, and few more. He has been National Science Academic Summer Research Fellow while aged 19 years old. Umang has also been an active speaker in the AI community as well as keynote speaker in the multiple national and international conferences. He is also one of the earlier contributors to the Google Colab, then called Google Data Lab. Umang is one of the early adopters of TensorFlow JS and has spoken about it in various conferences including Google DevFest, and has even authored a book on TensorFlow JavaScript. Umang, the virtual stage is all yours.
Thank you for the introduction. I'm glad that it's quite an introduction. I believe you guys can see me, right? My video is on, right?
Yeah.
All right. So good to meet you all. Thanks for the introduction. My name is Umang Sharma, and we will be talking about deep learning today and deep learning with TensorFlow JavaScript. Okay. All right. So let's get started. Let me share my screen. Please let me know once my screen is visible. Can you see it?
Yes, Umang, your screen is visible.
Sorry?
Yes, your screen is visible.
All right, let's get started. So this is going to be a fun journey. We'll talk about machine learning, talk about deep learning, we'll talk fun demos, multiple of these demos learning. And let's get started. Let me put this on a slideshow mode, and we'll get to it. Okay. All right, the topic of today's discussion, today's talk is it's called Deep Learning Made Easy, Fast and Deployable with TensorFlow JavaScript. My name is Umang Sharma. I'm a senior data scientist at a company. I've been doing this for years now. Doing AI is my passion. Today, the whole purpose of this talk is to make easy to understand, to let go of all that hype of machine
Umang, sorry
learning.
to interrupt. Hello, Umang, sorry to interrupt. Actually, your voice is not clear. It's breaking.
Okay, I'm not sure why that's happening. Any better now? Any better?
Yeah, it's currently better. I'll let you know if there's a disturbance.
Okay, let me check the this if I can create something. So that's the topic of today's discussion. Let's talk about machine learning. It's such a hype these days, right? Everyone is worried how difficult is machine learning or deep learning and things like that. Let's talk about it, right? So even that's my Twitter handle. In case anyone wants to connect with me, that's one way to connect with me. Let's go. So yeah, let's start with this meme. Machine learning is new cool thing. Everyone is talking about it, and some people say it's easy to do it. But I'm not sure, right? As this guy is really worried about this, that you are not sure that is this even a how difficult is this whole field. Let's talk about that. Some people would say it's easy to do it, some people would say it's tough to do it. We'll figure it out. Let's see. All right, so first of all, what is it and why do it, right? So why do we even need machine learning, and why are we even worried about Why are we worried about doing all of that in a GC? So first of all, it helps majorly in three things. It reduces the time that you need. So
So,
basically,
Umang,
yeah,
I think in the chat
yeah.
section, people are still mentioning that your voice is not clear. I mean, to many people,
Uh,
it's missing in
okay,
between.
let me do something. Okay, let me just
Okay,
rejoin. Okay, give me a minute.
sure.
Can you guys hear me now?
Yeah, it's audible and
It's
clear
audible,
also.
right? It's all clear. I think yeah, maybe the video is playing around something. I don't know what's happening. I'll
Okay,
share
you
my
can,
screen.
yeah, you can pause your video, not an issue.
Okay. Let me just go to the presentation. All right. I'm still audible, right? And screen is visible.
Yeah,
All right. Let's go to it then. All right. So we're talking about why machine learning, right? Why? What is it, and why do we even do it, right? That is super important, right? That first of all, it majorly helps in three things, as you can see on the slide. It reduces time. How? If you have to solve a problem just by programming rules, it's not an ideal way of doing it. I'll tell you why. Because let's say I have to solve a problem of recognizing faces. If I try recognizing faces just by programming rules, that is not the ideal way to do it. Why? Because how many rules can you make, right? You can make things like, okay, eyes have to come between eyes, nose has to come between eyes, and so on. But there can be infinitely many possible faces. So you cannot program everything by rules, right? You cannot just rule it right. You cannot write all the possible rules. It's not possible. That's why it reduces time. You don't need to program rules. Secondly, right, what is product customization, right? So once you have better machine learning in your products, product could mean your Gmail, your FaceTime, your Apple products. If you have that, you have smarter products. You can see all of us use Gmail, right? I believe most of us use Gmail. And in Gmail, we all have known about this something called autofill, right? It just fills your message. You are typing something in your email gets filled. Do you think it was based on rules? No, it is purely machine learning and deep learning. That's why you inculcate machine learning in your project or your product, and suddenly you have smarter products now. And let's talk about this one, right? So we have smarter products. It solves problems which can't just be solved by just coding, right? There are infinitely many problems which cannot be solved just by coding. You need to do a lot of other stuff. You cannot basically code everything and just go about it. That's why we do machine learning. That's why it's important. I believe that's clear. Let's move ahead. So it's a very three-step simple process in doing machine learning, very high level. It's like there is more to it, but the step is simple. You provide enough data, you put the right labels to the data, you train your model and you get results. Simple, right? So what do I mean by these three pillars, right, that you see? So provide enough data. Everything in machine learning totally depends on the data. You gotta provide enough data. And when I say data, it means you have to provide enough instances. So let's say I'll go back to the original problem that I'm trying to recognize faces. Obviously I cannot rule it out. I cannot make rules out of it, right? It's not possible that I just create all the possible rules and I'll be able to capture all the possible faces in the world. It just doesn't work that way. So what do? I provide enough data of faces, right? I provide the data about how does the Indian face looks like, how does an American face looks like, and so on and so forth. So there are multiple, you provide all this data and you are good to it, right? So put the right labels to the data. So you collected your data. Now let's put the labels to the data, right? So when I say put the labels to the data, so you have to tell it, right? Okay, which one is which? I provide a male face, a female face, its age, etc., etc. Train your model. So once you have your data, you have put all the labels to the data. You have basically mapped the labels to the data. It's time to train your model. You train your model, and results start coming in. That's how simple it is. It's not very difficult, right? That's the whole idea in this process of machine learning and deep learning too. So, okay, we have all been learning about hearing about this hype of machine learning, deep learning. But yeah, it's simple. It's just six steps. Obviously, there is more to it. We'll see about it. We'll see about it right now. Most of us, I'm assuming a lot of us would be programmers, or we have had some exposure to programming in the last recent past. Let's talk. If you have to compare traditional programming and machine learning, this is how you compare it. So in traditional programming, you have a computer, you give it the data, you give it the program. Let's say I'm trying to write a program to write 2 plus 2 is equal addition program. I'm trying to do addition. How do I do it? I just provided data that okay, these two digits or these two digits will be added. The program is to add them, you get the result. Simple, right? You just do the rules. You provide enough data. Sorry, not data, you provide the logic of the program, you provide the input, you are done. Data means like if I have to say I'm trying to do 2 plus 2 is equal to 4, 2 and 2 becomes data, the program is the addition logic, and that's it. Machine learning works in a totally different way. Machine learning, what it does, you have to first give the data and the output. Okay, what do I mean by that? That means that, okay, you give it the data, you see, coming back to my original example of recognizing faces, I give it some faces, that's my data, and I give it some output that, okay, this face means that's an Indian face, male face, that means the Chinese face, or that means an American face. So data is there, output is there. Now I let the computer figure out the rules. I let computer figure out the whole idea behind the process. How do, like, all the things that need to be figured out, computer will figure out for me. I don't need to write any rule. Computer will figure out the logic that how to recognize or classify faces. That's the difference between traditional programming and machine learning. So it's totally different, right? It's in that you provide data in a program. Now you provide data on output, and you expect a computer to give you a program that okay, this program will run and it will recognize faces from. That's how it's defined. Okay, let's move on. The difference, right? So first, I think we talked about that, how the difference is in the last slide. Let's talk about exactly in principle how the difference works, right? So we use assertions to prove our program is correct in programming. In programming, I use assertions, right? I write test cases. In Python, I write assert. That means that, okay, 2 plus 2 has to be equal to 4. That's my assertion. It has to be equal to 4. There is no other way. It's just a deterministic. It's like 2 plus 2 is equal to 4 will always be universally true. That's how I test my program. In machine learning, it does not work that way. You test by statistics and not logic, right? You cannot say that, okay, I give a face. It always has to be like this. You use statistics, okay, you use things of a probability that, okay, I'll use probability and, I'll determine that how my program is doing. In statistics, you use in machine learning, you use statistics to determine how good your program is doing. Are you 90% accurate or you are 80% accurate, etc., etc. So you have to understand all of that. Moving on, so that's the difference between machine learning and traditional programming. So that's how you define these two different pillars in computer science these days. And it's definitely, secondly, it's definitely got a lot of statistics and probability to understand how the things are going. If you don't understand that, it will be difficult to be a good machine learning engineer. Okay. Moving ahead, let's talk about evolution of application architecture, right? So if we look at the application architectures for some time, since the since 1990s to 2012, this is how the evolution has been. How, what do I mean by that? Is that let's say you have an application architect, you have a let's talk about the first pillar in this, that the 1991. What was happening at that time is that you used to have an application server which used to have data, used to generate all the logic for UI generation, and then your user interface, the browser, would send requests, HTTPS requests to the server, and that's how you would communicate with each other. So there will be a backend server, there will be a actual interface, a web browser which is your interface, and you will be communicating that via HTTP requests and CSS. It used to be very simple, plain vanilla, so not nothing fancy. It used to be old times, so things used to be very simple. A server, a front end, a server, and you are done. 2006, things changed at all. Things changed for some time. Things changed. How? Something called Ajax came in. Ajax means asynchronous JavaScript. What exactly does it? What was it doing? And Google started using it. By the way, Google. The whole idea of Google search works with your Ajax only. So the idea is that now what happened is that now your web server is actually staying in a server, like your all the business logic is still staying in the server, but now the request won't be HTTPS only, it will be Ajax requests, So UI, you can dynamically load UI, you can dynamically change UI, you can dynamically trigger few things in the UI, and data could be passed between backend and front end, the server and the browser asynchronously very fast. So if you ever type if you ever search anything in Google, right, it's using Ajax to fetch results for you. You type a query in the front end, it will go to the back end, fetch all the information and give, and suddenly it happens so fast and asynchronously that you won't realize that it's fetching server from the back end. You think like it's all everything is happening right now, right here. So that's the thing to understand here. That how do you differentiate these two things? Like what happened in 2006 when Ajax came in and Google started using it. Later on in 2012, things changed even better. Now you had something called MVC, which is model view controller, or MV star pattern, right? So MV star is basically model in view. Model would mean your data model, your application model, your logic. View would mean the front end of your application, and the control between them will just move on. That's how your model view is defined. MV is defined. When that happened, now things are better because now you have a properly defined pattern and you are still using HTTPS requests, you are still using raw JSON data, but the architectures have changed now. So that's how the application architectures have evolved over the years in terms of web applications. Obviously, I'm talking about web applications. Obviously, there could be different ideas about, what do you call it, mobile applications, TV applications. That could be different architecture. In this talk, we'll be talking about web applications because we're talking about TensorFlow JS, which works in web only. Okay. All right. So what's next? This is what the story was in 2012. But what happened after that? After that, TensorFlow JS came in 2016, and things have changed a lot, especially in machine learning and web apps area. Okay. Let's move on. All right. With that, let's actually see some machine learning, some fun in action, and let's try to play Pac-Man. I'll play Pac-Man using machine learning. I would like to give you a demo, and we'll do it right away. Let me just open that demo, Pac-Man demo, TensorFlow JS, and you go to here. I hope I am audible, right? There hasn't been any audio issue, right, so far.
Yeah, now you're audible. Not an issue.
Perfect. And the screen is visible, right?
Yes, yes.
All right, so I think we've all played this game, or we definitely know about this game called Pac-Man. This yellow guy would move. We'll have to move and find as much as points as possible. We will play today. We'll play Pac-Man using machine learning or deep learning. It's basically deep learning that's happening. What we'll do is that we will actually control the Pac-Man with our movements. I'll train a machine learning model right away in this call, and we'll start playing. What I'll do is that I'll add 4 data samples. So I was talking about adding data, right? So, but let me put this. So if I do this, I'll add an example here. This would mean the Pac-Man should go up. Let me add something for left. This would mean the Pac-Man should go left. This would mean Pac-Man should go down. Let's add something for right too. This would mean Pac-Man should go right. Okay. So I've given it 4 data samples right now, and I've told it that okay, what would because it's what would be up, what would be down, what would be left, what would be right. So you've given your data, you've given your output. Time for a machine to figure out the program or the model. It's called model. So it's training right now. Okay, it's training. It will be done in the seconds. All right, it's trained. Let's start playing. All right, let me it's trying to go left. Can you see the yellow guy moving? That's moving with my movements. Right. All right, let's try to take it right. Let's see how good I'm okay. I have to give this. Yeah, let's try to. Okay, I got beaten. Let me try again. It's a fun game. Okay, so I'll try again. Up, then left again, then up. Yeah, left again. Okay, I just went up. Okay, came back. You see what's happening? The whole Pac-Man is getting controlled with my movements. This is fun, right? That's the power of deep learning, guys. That's the power of deep learning in machine learning. Before we jump in, this is the fun demo I wanted to show first. I have more demos planned for you guys. But what just happened right now is that you just gave it data, you train your model, we just train the model right away, and now we are playing Pac-Man easily, fast enough, right? What is happening right now is that there is a huge machine learning neural network running behind the scenes, which is taking my example and telling Pac, which is taking my directions and telling Pac-Man to move around. So it's still taking, as we speak. So it's still moving, if you see. Okay, I got out. All right, this was the first demo. Let's talk about what's happening right now. Okay, so I'll put this into slideshow mode. All right, we just had fun. So what exactly happening right now is happening about, okay, let me give you one more. Before we go to the details of what was happening in this demo, let me tell you what exactly used to happen. We're talking about, let's say, what was happening before TensorFlow JS, right? What was happening before TensorFlow JS was that you still had your MV Star engine that was in 2012, but now people started using machine learning. So you had a machine learning backend, and obviously you had a data layer, which is basically where you store all your data. This is how things happen in industry. So you have a big data layer, you have a machine learning backend layer, and Ajax would just take stuff from from this. It will run your model, get the results out of it, and come back here and give it this. So question means trying to get the results, and answer is the result itself. That's how it was happening before TensorFlow JS came in. What happened later is that now TensorFlow JS came in. Let me deep dive on what was happening in this demo. Okay, let me deep dive on this first. So what was happening in this demo is that data source is my webcam. My webcam was running, and it was capturing my live feed of what I was doing right now, all the actions I was doing left, right, and center. And then the data source was going to browser, your web browser, which is Google Chrome, which I was just using. And what was happening is that then your browser has a rendering engine. Rendering is nothing but it's taking all the graphics of the Pac-Man that you're seeing. Then comes TensorFlow JS. So TensorFlow JS is basically taking care of all the machine learning part of this. So demo I was showing right now, that TensorFlow JS would go to a model which is basically a neural network model. This model is called MobileNet. MobileNet, what it does is that it just takes your images and it classifies and tells, okay, an image when I'm doing a finger up is an upper, it's basically an up direction, and when I'm doing the left is a left direction, etc. So the TensorFlow JS is taking care of the machine learning part. Everything else is happening in browser. The best part of TensorFlow JavaScript is that you don't really need complex stuff for it. Everything happens in the browser itself. That's the best part. You don't need big machinery, servers, and all those things. Everything happens in the browser itself. That's the best part about TensorFlow JavaScript. It's very lightweight. You'll be double clicking on that. Let's move ahead. All right. So what happened to server now? Server, no one talks to server anymore because everything is happening in the browser itself, your front end. No one talks to server anymore. That's what the browser says, that now you're just somebody that you used to know. So because now it's not talking to the server anymore. So server is secluded. No one's talking to server anymore. Server is lonely. Everything happen in the browser. That's the best part. Let's move on. What if I told you what was just happening was regression? It will be funny, right? So I know things would have been good, but it wasn't regression. There was slightly much more than that, but yes, some part of it was regression. I wish it was all regression. That would be life would be easier for data scientists like me, but it wasn't just regression. It was much more than that. Let's move ahead. All right, so we spoke about how machine learning works. We just did a deep learning demo. Let me give you a very high level picture of machine learning versus deep learning. Okay, so let's say I'm trying to, I'll take a different example in this slide now. Let's say I was trying to predict that if I give an image, is that a car image or not? Is this image of a car or not? Let's say that's what I'm trying to do today. I give an image to the machine, a computer. I give nothing else. I just give an image and I want to ask it, okay, machine, tell me, okay, computer, tell me, is this image of a car or not? Simple problem, right? Classify an image as a car or not. Simple problem. Let me tell you how machine learning does it, and then we'll talk about how deep learning does it. So the first thing that we do in machine learning is feature extraction. So what will happen is that if I have to solve this problem using machine learning, first thing I'll do is extract features. What are features? Features are nothing but your representation of your data. I have an image of a car. I need to get out useful features. So I just cannot use a raw image and tell it that just from the raw image I cannot tell. I need to extract more information out of it. There are multiple ways of doing it. You extract the patches of the image, you extract the corners of the image. You basically extract some key information about the image, and that's how you tell, okay, that I have extracted my features. Then I'll run a model on my data, all my features. Feature is, as I said, a different representation of your data, some meaningful information from your data. If I've gotten the right features out, I've gotten the feature representation out, I'll be passing that to any model that was built earlier, any classification model. There are so many models in the world these days. I'll do that model, I'll let that model run, and I'll get me the output. That's how I'll do things in machine learning. I'll take an image, I'll get the features out by hand, by using some algorithms, by using some mathematics and statistics, and I'll put that pass that to already built model, and then it will work. How do I do it in deep learning? That's the interesting part. In deep learning, things work differently. In deep learning, you don't really need to do feature extraction as such. Why? The models in deep learning, way we design deep learning models, it will take care of finding all the features. It will take it just have to give an input image. Your model will take care of finding the patterns, these features, everything that has to go around it. It will take care of all of that and will give you directly the results. So you pass the image as an input, let deep learning model will figure out the features, extraction, the patterns, the patches of the image, everything meaningful about that image. It will run its model, and you're good. You're done, and it will give you an output. That's how things are differently done in deep learning versus machine learning. Obviously, there are pros and cons. Deep learning is more complex, more deep learning has a lot of stuff to it. Machine learning is more classic, simpler models. Deep learning are complex models. You need a lot of compute to run these models, and so on and so forth. Okay. So that's how things work in differently in deep learning and machine learning. Let's talk about TensorFlow JS. That was the biggest topic of this talk today. TensorFlow JS, right? So as I said, TensorFlow was introduced by Google recently, just 5-6 years ago. And TensorFlow JS is basically JavaScript version of TensorFlow. Now, what is TensorFlow? TensorFlow is a machine learning library which was created at Google, by the Google, for the Google. Later, they open sourced it, and everyone can use TensorFlow now. So TensorFlow.js is basically JavaScript version of TensorFlow, and it will take all the work that needs to be done in everything happens in the JavaScript itself. All right. Here are the three workflows that you can consider using TensorFlow.js. You can import an existing pre-trained model for inference. So, someone could create a model and you can directly import and you can directly use it. That's what we did in the Pac-Man example. There was a model that was already created by someone. I just went out and used it, again using TensorFlow.js. Then you can always retrain an imported model. What is imported model is that, you took someone's model, added your data, and you retrained it. That's also possible in this scenario with TensorFlow.js. You can even write your models from scratch. You can write your everything from scratch itself. Okay, that's also possible in TensorFlow JavaScript. So that's the high level idea of TensorFlow JavaScript. What you can do with it, you can write your models, you can retrain your models, you can load an already existing model, etc. There is also you can do data visualization in TensorFlow JS. We will have a look at it if time permits. We'll see. All right, so I'll take a pause, and I want everyone to I'll take a pause for 2 minutes, and I'll take any questions right now in chat if any, so that we can move ahead. That's like I want to be empathetic towards the audience and understand if they have any questions before we move on to the next part of the talk. Obviously, we have dedicated time slot, last 15-20 minutes for the questions itself, but I'd like to take few right now. All right, so I see a question: is TensorFlow Js easier than Python? Yes, definitely easier than Python if you know JavaScript. And in general, yes, even if you don't know JavaScript, it's easier to read and write TensorFlow JavaScript. It's faster. You don't really need to understand. You don't really need to install a lot of stuff. Like you have in Python, you have to create an environment. You have to create stuff. In JavaScript, it's super easy. You just have to do an npm install TensorFlow JavaScript, and you are done. You can directly write code, test your code in the browser itself. So no fancy machinery required. No fancy libraries required. It's simple. So yes, TensorFlow Java is difference between NumPy and TensorFlow. Okay. So NumPy is basically for numerical computations. Numerical computation means NumPy is for doing things like do matrix multiplication, do your find the mean of the matrix. It's basically all about matrix computations, numerical computations, find the mean, do an integral, do a differential of this function, etc., etc. NumPy is basically a scientific library, which is it's a scientific library which is used in Python for scientific computations. NumPy has got nothing to do with machine learning. It's a purely scientific library for scientific calculations. TensorFlow is a purely machine learning library. It's only used for machine learning, and all the machine learning modeling, your deep learning, everything has to be done in TensorFlow. Okay. All right. So I'll take maybe a couple of questions and then we'll move and I'll answer remaining questions in the end. Okay. The question is, can it be used in Azure or AWS? Yes, absolutely. As long as it's such as JavaScript, right? As long and AWS, you can have your virtual machines or any sort of machine. As long as you have a machine and you have you in your virtual machine, you can deploy your JavaScript code. It's all good. Yes, it can be used in any cloud right now. Any cloud, any browser. Definitely can be used in AWS Azure. Can we use TF.js in edge devices? Yes, you can. In fact, people have developed a lot of stuff in edge devices. People have done a lot of IoT stuff using edge devices. Reason because it's very lightweight. So you basically take a Raspberry Pi or some device like that and let your JavaScript code run there. It will be easier and faster for the device as well. Yes. Okay. All right. We can move on. Yes, they were. Okay, I'll take one more question maybe. How to use a text format model with data format of client series for LSTM. So H5 is a very common model saving format. What it does is that it's basically a model saving format. And yes, you can definitely load a H5 format in TensorFlow JavaScript. What you need to do is basically do a dot load model in TensorFlow or TensorFlow JavaScript. It will load your model, and then you can run it anything that you want. So that's about loading. I'll take the rest of the questions towards the end. Okay, I'll move on. So we spoke about TensorFlow JavaScript. We'll move on. All right, I'd like to also double click on what's happening inside TensorFlow JavaScript. Okay, there are a few layers that we need to understand. So let's say I have developed a new model for me in TensorFlow JavaScript. How does the layer stacking looks like? So this is how the API structure of TensorFlow JavaScript look like. The highest level API is Layers API. Layers API lets you write models, custom models. You can write your deep learning model, machine learning models using Layers API. Then all that code, all that computation goes to Ops API, which is basically taking care of all the operations, which then goes to browsers, and browsers in turn goes to WebGL. WebGL is the browser backend. Every browser uses WebGL to render images or render things. So ultimately, what's happening is that it's Layers API, then it goes to Eager API, which is basically converting your Keras model API or the high level API to a lower level API, then to browser, then to WebGL. WebGL is the heart of any browser, by the way. That's how the TensorFlow JavaScript layers are stacked like an onion. That's how it's done in TensorFlow JavaScript. So that's how you do it in Keras. That's how we've done it in TensorFlow JavaScript. Let's move ahead. So that's how TensorFlow JavaScript is defined. But in general, any machine learning application, how it's defined, you first start by defining data sources. Okay, what do I mean by that? Let me take a very good example. This slide is more of about talking about how machine learning or deep learning works. Let's say I'm trying to predict a customer's behavior pattern. Let's say I have a supermarket store like Walmart or Vishal Mega Mart or anything DMart, and you are trying to predict that, okay, how many what I want to predict what will customer buy next week or next month. I want to predict their buying patterns so that I can give them good deals accordingly. So let's say someone is buying a lot of cornflakes every fifth of every month. I want to make sure that using machine learning, I should be able to predict that this person consumes cornflakes on 5th of the next month. So I should be giving them some offer so that they come back to me and buy it from me itself. So that's a simple problem. Let's talk about how do I do this with machine learning. So first thing is I define the data sources. So define all the data sources, right? So in case of a Walmart or a DMart type of system, you definitely need to define, get data, right? There can be many sources of data. You can check their buying patterns, the sales they have done. You can check the amount of time they have visited the store. You can check if they are a loyalty partner or not, like they have your ID card or not, like Walmart customer ID or not, etc. So start by defining the data sources. What of data do I have at my disposal for solving this problem? First thing to understand. That's what a data scientists do. That we first define all the possible data sources that are available in this problem. We look at all the data, we analyze the data. Then I say, okay, amongst this data, this is what I want to use. Okay, I figured out I want to use this data. What next I will do is that I will stream and channelize the right data. So when you have the right data in industry level, you have to stream it, right? You have to let it pass. You have to do a lot of stuff with it to basically load your data. Basically, you have identified your data sources. You have analyzed a small chunk of it. Now you will basically load this data. You have to write big data streams, Spark streams to load this data. You have loaded the data. Now you run your model, basically train your model on the data. You can use Python, TensorFlow, PyTorch, TensorFlow, JavaScript, etc., etc. You've gotten your data, you have understood your data, you've gotten your data through big data and Spark streaming, etc. You have run your model on that data. Now you can infer from the data. Infer means that you can let the model predict from that data. That's how any typical machine learning life cycle is defined. That's how we do it. Okay. So that's how any typical machine learning life cycle is defined when you are trying to design ML application, irrespective of you do in TensorFlow or you do in PyTorch, etc., etc. Okay. I believe so far so good. Let's do a few more demos, and then we'll just I'll explain about the demos, and then we'll take more questions. All right. Just a minute. All right. Let me first go back. Let me first show you the power of TensorFlow JavaScript. This is going to be a fun example of how machine learning works in general, and we'll use TensorFlow JavaScript with that. So we would first start by visualizing training in TensorFlow JavaScript. What we'll do, we'll load some data, we'll train a model, and we'll see the model training itself right in the browser. Okay, let's do it. So let's show the visor. So visor is basically, this is going to be my output pane, where I'll show all the output what I'm discussing right now. You will see here. All right. Let's make a surface. Surface is another one element of the visor. Visor is this whole white screen, the white part of the screen. Surface is where you will see your plots or the visualizations. Let's load some data inside. So I'm loading some data right now for this model, and I explain what I'm trying to do right now. So we have loaded a dataset called MNIST. MNIST is nothing but MNIST is basically 60,000 images of handwritten digits. So I'll basically have an image of handwritten digits which are written by hand. I have 60,000 images of that, and this is a very common dataset, a starter for a lot of machine learning problems. So this is how the dataset looks like, by the way, handwritten digits. And what the problem is that we will train a model that will try to see these images and try to tell me which digit is this. It will see, I give this image. It should be able to tell me that that's a 3 or that's a 5 or that's a 2. It's a handwritten digit, and we'll try to predict which exactly the number is behind the digit. Okay. So start training the model. Okay, let's start training the model, and you will see some stuff. So what is happening right now is that, yes, you see a few things. So there's something called an epoch. This is loss. And so if you see, we want to decrease this value, the loss value, and we want to increase the accuracy. This is a loss curve. Loss is how we define a machine learning model. Like there's obviously much more to it. Enough, not possible to cover in this talk, a lot of it. But in a very high level, we want to decrease the loss as much as possible, and we want to increase the accuracy, obviously. So with this the model I trained right now, I was able to increase the accuracy of 79 or something. Yeah, we increased the accuracy of 79%. And the loss has been reduced to 0.12. Okay. And this is again a loss curve, but this is a slightly different loss curve. It's a smooth curve, and it's basically obviously this is all done in browser by TensorFlow JS. And let's see the custom charts. Okay, we've done that. Let's evaluate the model. Okay, so we've trained the model. We did some testing as well. This is how the training is done. We can see some evaluation. So when we gave it 0 images of the number 0, it was 96% accurate, and it was tested on 63 samples. When it gave the image of the digit 1, it was 100% accurate. That's why the accuracy is 1. For 2, it was 85, 3 for 92, and so on and so forth. Interesting, right? We just trained a model, and we got all the accuracy and all the curves, all this stuff right now in seconds. We can also look at the confusion matrix. So the confusion matrix is a very good example way of representing data in machine learning. When you are presenting this to someone, this is a very good idea. So what we need to, how do we look at the confusion matrix? On the left, on the y-axis, the label, and this is the prediction. So what happened is that when the label was 0 and the prediction was 0, it happened 43 times. But when the label was 1 and the prediction was 0, that never happened. But even one time what happened is that if the label was 5 but the prediction was 0, label means that this what happened right in this cell is that the given image was of the digit 5, but my model said it's a image of digit 0. It happened one time and it happened twice for the digit 6. So that's how it's very good idea of how confusion metrics tell you that what has exactly happened behind the trailing. So that you can see diagonal is what we should be looking at ideally, but this gives you the idea of what was happening at the other examples as well. Okay. This was about how machine learning is happening and how it happens in general and how you look at these curves, how to understand these curves. This is we looked at the input data, we looked at the model training, we looked at the curves, and then we look at the evaluation as well. Okay. That was about how machine learning is done in general. Let me give you one more fun demo. This could be fun one. Let's go about it. Let me close this one. Let me open this one. So what we'll do is this is a very beautiful demo written by using Tensorflow JavaScript. What we will do is that we will draw on screen right now. We will just draw a screen using my pinch. Let me allow the camera. All right, I'm back on the screen. Let me try to give it my hand. So what I need to do is I'll make a pinch, and whatever I try to write on the screen will write for me. I just try to make an M. Let me try to make it A, N. I'm trying hard to. If you get it right, it's basically understanding my hand movements. I'm trying to write it. Okay, I did not go. Let me remove. So I do this and it gets it up. It removes. Let me try to draw up. Let me remove it again. Let me try doing it. So I'm trying to do a triangle right now. Fascinating stuff, right? Okay, triangle, but a bit messy. Fascinating stuff, right? What we just did is that it's basically tracking my hand. If I do this, it's capturing all the input points of my hand. It's capturing the movement of my hand. As you can see, everything is getting drawn on screen right now. That's the power of deep learning, guys. And I can just remove it right now. So basically, it's capturing all the key points of my hand, and now I can draw on screen in the air itself, right? Magical, right? And I'll just remove it. Interesting, right? This was done by using TensorFlow JavaScript. Simple. No, everything is happening on the client side in my browser itself. My video is safe. No one is able to see my video. As I said, it's particularly an open source project, and it's so much fun, right? I can do so many things with it. Right. All right. Was one demo. Let me do one more demo. Another demo. This was a fun demo, right, guys? So that we just did was that so what's happening right now is that we are using a model in this called BodyPix. What it does is that it captures the hand movements of my hand, and whatever I do with my hand, it draws a color around that, it draws a paint around that. So it's basically the idea is to capture your hands first and then do stuff about it. Okay, we'll do one more example that will give you more clear picture. This is called pose detection. Okay, I don't know why this opened, but okay, let me do 3 demos now. Okay. First, we'll talk about MoveNet. What MoveNet does is that it captures your key parts of your body. Not sure why it's not loading. It takes some time to load sometimes. Yeah, there it is. So you see what's happening. It's able to capture major body parts of my body. So it's able to capture my shoulders. It's able to capture my arms, my eyes, my nose, and my ears. So we see right now, everything is getting captured. It's able to draw a stick figure of me. Right now, it's happening live in your browser. No fancy stuff here. Everything happening in your browser. That's the idea, right? So this is again using TensorFlow JavaScript, nothing fancy. MoveNet is the model that's getting used, and I'm able to capture all my body parts using this. Interesting, right? Let me do one more demo. So this is called MoveNet, by the way. Simple using JavaScript and my browser. No heavy computing here. Let's try this one. This is called BlazeNet. Blaze Pose actually, not Blaze. Blaze Pose. Similar stuff. So it's capturing even more key parts of my body right now. So that was capturing very few. BlazeNet was capturing very few. Sorry, the last one was capturing very. MoveNet was capturing very few. Blaze was captured even more. So you see, it's capturing my fingers and tried to. The example I was just showing a while ago, the handwritten thing is using internally something like similar to Blaze Pose. It's basically able to identify the key points of my hand, and when I make a fist or something, it recognizes that and it starts to track my finger movement. It's able to draw everything that I need to. It can capture few key points in my eyes, my nose, and my lips too. Interesting, right? Super interesting stuff, right? So this is happening using Blaze Pose. Even it's able to capture even if you see it's capturing my elbow and many finger points in my hands. And no fascinating heavy machinery, no GPUs required. Purely the power of machine learning in browser. Nothing has heavy happening here. Okay, one more demo and then we'll discuss. Okay, PostNet, my favorite one. My chapter of my book actually has a lot. I have a whole dedicated chapter of PostNet in my book. PostNet is again simple, but it's a slightly version. The same thing is happening in PostNet as well, but it's lightweight and faster because it detects a less amount of points. So it all started with PostNet initially. So everything started from PostNet, and then Blaze Post came in, which is complex, and MoveNet is also decent. Okay, so that was the idea. And let's go back to the slide. Right. So yes, that was about it. And I have authored a book on deep learning on deep learning with Tensorflow Js with Wiley. It's hoping to be published in the coming week. And if you want to connect with me on LinkedIn, this is the QR code to scan. This is my Twitter ID to scan. I'll keep this open, and while this is open, take all the questions. So I'll go to the chat and I'll look at all the questions from where we left last time. Meanwhile, if you want to connect with me on LinkedIn or Twitter, this is the place to connect. All right. I suppose was the last question I answered. So the question that I have is how to start TensorFlow JS if not know nothing anything of JavaScript. Definitely a good question. So you go to tensorflow.org, you look for TensorFlow JavaScript, you will find ample amount of tutorials there, which can get you started on TensorFlow JavaScript. You don't need to install anything very fancy, as long as you are able to install Node.js. Even that is not required at times. You don't even have to install anything. You can do everything in your browser itself just by using pure HTML. It's that easy. All right, the tensor, does it mean TensorFlow has to do with cloud computing? No, they are not related. Yes, you can do TensorFlow on cloud, but they are not equally related. They are not mutually exclusive or mutually exclusive. This is not, they are not connected. These are two different things altogether. Is TensorFlow JavaScript an interface to implement deep learning model? Yes, definitely. It's indeed an interface to implement deep learning model directly in a browser. That's the power of TensorFlow JavaScript, that you don't need anything. You can do everything in the browser itself. For image processing, JS or Python, you can do both. If you want to do everything in your application, in a cloud in your web application with JavaScript, go for TensorFlow JavaScript. But if you want to do heavy image processing and it does not necessarily have to do with an image, an application that does not involve JavaScript. Basically, if you don't have a JavaScript application, you can do it in Python, no problem. What is TensorFlow versus scikit-learn? Scikit-learn is again a scientific library. It has some basic scientific programs and functions to be used. That's about scikit-learn. So you can do few basic stuff like data, pull data using scikit-learn, but that's about it. For more complex stuff in machine learning, you have to do TensorFlow. Okay, which one do you recommend for a beginner, TensorFlow JS or Python? It all depends on the background. If your background is a Java developer or is a JavaScript person, you are a web developer or you have developed some JavaScript application in the past, definitely start with TensorFlow JS. But if you're starting from scratch, you have no idea, no background in machine learning or deep learning or AI, Python is the way to go. All right. Don't we require more RAM, CPU, GPU? No, that's the beauty of TensorFlow JavaScript. Most of the stuff can be done in browser under lightweight. Yes, there is indeed a possibility of using TensorFlow JavaScript, and you can utilize GPU using TensorFlow JavaScript. There is indeed a possibility of doing that. TensorFlow JavaScript can utilize your GPU, but you don't necessarily have to have it. You can't have it, and you can still train your model. It's up to you. Is TFJS more toward computer vision? No, absolutely not. TFJS has so many applications. I could show you so many more demos. Yes, today I only show TensorFlow demos in computer vision. but TFJS can do NLP, TFJS can do reinforcement learning, it can do so many other things. The possibilities are endless. The possibilities are endless. And don't we have any counterpart for TensorFlow.js from PyTorch? No, we don't. There is something called Keras.js, Keras.js, that's about it. In PyTorch, there is no JavaScript counterpart as such. So those were the questions I had in the chat. I have one in the Q&A. Okay, I have, yeah. Do we require higher RAM CPU in JS? No, we don't. It depends on the model. If you're not doing anything extremely heavy, you don't really require a lot of RAM. A basic computer would do. I'm running a laptop in my 8 GB with this MacBook with 8 GB RAM, and you don't really require, a lot of stuff in this. It's very lightweight. That's the whole idea behind TensorFlow JavaScript. Otherwise, we could do everything in Python. All right, I'm open. We still got like 6 minutes. I can take few more questions. I'm happy to take more questions. All right, I have one more question. Is it always necessary for the model to have larger data to train the model better? Yes. The whole promise of deep learning, the whole idea of deep learning, you do need a lot of data. Otherwise, deep learning doesn't work. You do need to have a lot and lot of data. Otherwise, you cannot expect a model to learn all the possible ideas in deep learning. Yes, you need to have a large data. Yes, there is one way of doing it. So when I was playing that Pac-Man game, I only gave the data of 4 images in Pac-Man. So that was just 4 data, but that was using retraining. I was retraining a model. I already had a trained model. I just retrained it using my data. So this model was trained on some other task earlier. It already had some training. I just gave it 4 more images for my local task. So in that way, you can, you don't have to give it a lot of data. Otherwise, you have to. If you're training from scratch, you do have to give a lot of data. Which has more compute scope, computer vision and NLP? I think both of them have equal scope. My job so far has involved both of them. Both of them have equal scope. It all depends on your interest and what the business is asking for. You could work with images or text. Both are equally good and equally have good scope. In this field, there's a lot of scope. Can we compare the inference speed using TFJS and KF Python? I don't think it's an apples to apple comparison. Why? Because these two are both different worlds altogether. JavaScript is browser based, and Python you could have any hardware. You could use a GPU for inference too. But if it's a lightweight model, TFJS is the way to go. Any other questions, guys? I got one more. Is it possible to use data from a database for training the model, or how can we get the data? Yes, you have to store data somewhere. Otherwise, there is no other way to retrieve the data. And yes, TensorFlow JS can retrieve the data from any place you want. It is indeed possible to retrieve data from TensorFlow JS. In fact, there are a lot of functions to retrieve data using TensorFlow JavaScript. It's very there are so many functions and APIs in TFJS that will help you retrieve your data. Uh, like pre-trained model, like mobile network for CNN, is there any pre-trained model for sequential data as well? Yes, there are a lot of pre-trained models. You can look at LSTMs, you can look for transformer these days, that's very cool. You can just go to tf.tensorflow.org, look for TensorFlow JavaScript, and you will see a lot of pre-trained models for sequential data as well. You can. There's even possible for time series. It's possible for structured data as well. Every type of data, you will find the examples and tutorials for that. Does TF.js support ARM? Yes, I think yes, it does. Definitely does. Can I use TF.js rather than Python for training basic ML for students? Yes, you should. Why? There should not be any reason for you to not use Python. Python is definitely the language to go to. TF.js is just an alternative. Definitely, Python is what most of the people use in industry. I see one more open question. Can you share some resources to get you start in Python? That's a very common question. I think Python you can learn from anywhere. You can learn tutorials point. You can learn from pythonviz.com. Just before you start machine learning, definitely do understand Python. Definitely learn Python. Don't start doing machine learning without learning a programming language. And if you don't know any programming language, definitely learn Python first. Is DevOps knowledge useful for helpful data science field or not? No, it's not. Data science is a different field. DevOps is useful when you are deploying your models. So yes, it does. It gets useful, but that's about it. You don't really have to have DevOps for sure just to be a good data scientist. It's good to have in a longer run to be a full stack person. Otherwise, you don't get DevOps at all. DevOps is not the data science field at all. It's basically more of a software engineering DevOps type of situation. Okay. Any other question? Are we getting PDF for this session? Organizers can tell you. Organizers can tell you. Is it possible to use tf.js in website? Yes, absolutely. That's the whole purpose of Tensorflow JavaScript. You have any web application. It could be a website. It could be a Node.js project. You can use that. That's the whole idea of Tensorflow JavaScript. Any place you have a JavaScript, any place you have JavaScript, and you want to do machine learning, tf.js is the way to go. All right, we are about time. I can take one more question, last question. Let's see one more. Okay, I answered it. Okay, last question is how do I form a data set for a low resource language in NLP? NLP is a broad system. You can have a question answer data set. You can have a text classification data set. You can work on a very common problem of sentiment analysis of Twitter tweets. So simply you can basically there are so many data sets available for doing it. You can just Google it. Very simple. All right. I think yeah, we are about time. Over to you.
Okay, thanks a lot, Umang. On behalf of Analytics Vidhya, I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future.
Thank you for having me, guys. You have been a great audience. I had a good time. I hope you also learned something and had fun at the same time. Because every time I do a talk, my whole intention is to make everyone understand and have a good time and make them interested more towards machine learning so they can go home and learn more and get back to me for more questions. So you can get back to me for any questions on my Twitter or LinkedIn. I'll be happy to answer. Thank you, everyone. It was a good session to talk with you all. My book is getting released next week. So if you want to learn more about Tensorflow JavaScript and deep learning, it has a lot of code. Please do purchase it. Okay.